Hello everybody, this is Miss Werner. We're going to be working on the Punnett squares on the back side of your guided note sheet. We're going to be starting with number 10. We did these together in class. However, if you missed that or you just want to review, watch this video. We're going to do them together. So starting with number 10, we're going to do a monohybrid cross. We're just looking at one trait. That's what monohybrid means. And we're going to start by making our key. We are going to do the ability to roll your tongue as our trait. I'm going to start with our key for the alleles. So first off, we're going to start with the big R. The dominant allele would be rolling your tongue. If you can do that, that is the dominant allele, versus the recessive allele, the little r, is going to be non-rolling. Okay, so there we have our alleles. Now I'm going to draw a line under that. I'm going to do my genotype to phenotype key. Genotypes are the two letters you have. Phenotypes are the physical appearance of that trait. So starting off, if I have two big R's, I have two alleles for rolling. That person is going to be able to roll their tongue. That will be their phenotype. Next up, the heterozygous genotype, one of each. If I have a rolling and a non-rolling allele, the rolling allele is going to shine through because that is the dominant allele. So that will also be rolling. Finally, if I have two little r's, two little non-rolling alleles, that individual is going to be non-rolling. So key is done. Next up, in our problem, says the dad cannot roll his tongue. That means, looking at our key, his genotype would have to be little r for the dad, because he's non-rolling. Little r. Then we're going to do an X. That means we're going to cross him. Mom, it says, can roll her tongue. We're going to assume that her genotype is big R, little r. Okay, so we have the two genotypes of the parents. We are ready to move on to the Punnett square. To make a Punnett square, draw yourself a box with a cross in the middle, so you have four nice quadrants. And you're going to take those parental genotypes that we just wrote down in our last box, and we're going to write them on this box. So it doesn't matter where you put mom and dad, as long as they're both on the outside. You could switch the placements if you wanted to. For example, you could switch these two, right? But let's put them here for now. Now we're going to distribute these R's. So this big R is going to come in this box and in this box. So we have a big R here, big R here. Okay, then we're going to take our little r. It's going to go here and here. Little r, little r. Now let's do the top ones. Little r is going to come down here and down here. And again, little r is going to come here and down here. All right. Punnett square is filled out. Now we're going to move on to the results. We're looking at this Punnett square to determine the results. We're going to do both genotype results and phenotype. So I'm actually going to break this box in half. If I go like this, we'll do genotype first and then phenotype. Genotype, we're going to look at what different genotypes we have in our box, what combinations of two letters we have only on the inside of the box. So looking at that Punnett square, first option we have big R, little r. So that's my first genotype. My other genotype that I can see in this box is little r, little r. Okay, these genotypes, now we're going to count how many of them we have in the box. So for big R, little r, we have two of them. You can see them right here. Two of them. And there are four total spots in the box. So 2 out of 4 is equal to 1/2, or 2/4 is 50 cents, 50%. We want to get that percent because we are talking about probabilities when we are doing Punnett squares. So we get my pen back out. Big R, little r, 50% chance the offspring will have that genotype. Versus our other genotype, little r, down here, again, 2 out of 4. So that one will also be 50%. Okay, so there we have our genotypic probability. When we're looking at a Punnett square, we're not saying that these individuals are going to have 4 children. 2 of them will be big R, little r, and 2 will be little r, little r. Instead, what this is telling us is the probability. So 2 out of 4, or there's a 50% chance that your child will have a big R, little r, and there's 50% chance that your child will have little r, little r. Okay, it's not going to be out of your total children 2 out of 4. Moving on to phenotypes, this is where we're going to look back. Let me get my handout here. We're going to look back at our genotype phenotype key. We already have our genotypes big R, little r. We look at our key, it says big R, little r. Let me get my pen out here. Big R, little r means rolling. So our first phenotype we have is rolling. And we're going to use the same percent. Rolling is going to be 50%. Okay, next one, we have little r, little r. If we look back at our key, we can see little r is non-rolling. That's our other phenotype. That one will also be 50%. We're taking this number right from our genotype key. And there we go. We've solved our first monohybrid cross together. Next one, we're talking about flowers, different petal colors. Okay, this time we're going to make another key. We're going to use R again. You can use whatever letter you would like. It really helps if you pick a letter that has the uppercase and the lowercase look pretty different. Otherwise, it can get a little bit confusing. So, starting off, let's do our alleles. Okay, dominant allele, it says, is red. So our big R will be red, and our little r is going to be the recessive or the white. Okay, section that off. Now we're going to do our genotype to phenotype. Okay, so again, we're going to have big R, big R, big R, little r, or little r, little r. Big R, we have those 2 red alleles. That's going to be a red flower. If we have one of each, that's the heterozygous, one of each. The dominant big R is going to shine through, so it's going to be red. But if we have 2 white alleles, we will have a white flower. So there's our genotype phenotype key. Now, we got to figure out the parents. It says to cross a heterozygous red flower with a white. Looking at that word, here we go, heterozygous. That means we have 2 different alleles. So we are going to be using this big R, little r. It's going to be both of our parents. That is the heterozygous. So we're going to put that in here, big R, little r, crossing it with another big R, little r. Now we're ready to put this into a Punnett square. So draw yourself a nice little square, big R, little r, big R, little r. And again, we're going to distribute those r's. Okay, so we'd have big R, big R, big R, little r, big R, little r, and little r, little r. So your Punnett square should look like. So we're ready to talk about our results. Oop, let me scroll over here. Results would be, we have 3 different genotypes this time in our box. First one, we have big R, big R. We also have big R, little r, and little r, little r. In our box, you can see there's only one that is big R, big R. So 1 out of 4 possibilities would be 25% or 1/4. 25%. Next up, big R, little r. We have 2 of these. See them here. So that would be 2 out of 4. 2/4 or 1/2 is 50%. And last off, we have little r, just 1 of those out of 4 total. So that would be 25%. Okay, this is where things are going to change a little bit when we get to the phenotypes. So looking back at our key, oops, undo that. Looking back at our key, we can see big R is going to be red, but big R, little r is also going to be red. So what we're going to do, we will write down that phenotype of red. But in this case, we actually have to add both of these probabilities together because they will both make a red flower. So we're going to have 75% chance of getting a red flower. White is going to be the same as we've done in the past because we only have one option for a white flower, which is that little r. So it'll be this one, right? So white will still be 25%, just like little r was. All right, with that, that's going to be the end of this video because this is getting a little bit long. There will be another video going over 12, 13, and 14. But if you are following along with this video, you are in good shape to be successful in this biology unit. All right, have a great day.